Imagine driving towards a huge mountain. You can't actually drive through it, right? Limits in calculus are kind of similar. They help us understand what happens to a function, our car, as we get closer and closer to a specific point, the mountain, without actually reaching it. They are super useful for understanding how functions behave at certain points, especially when things get a bit strange. Limits help us define continuity, derivatives, and integrals, which are fundamental concepts in calculus. They are crucial for understanding how things change over time, such as velocity and acceleration. Now imagine you're trying to calculate the speed of your car at the exact moment you reach the foot of the mountain. You have zero distance covered in zero time. This gives us 0 divided by 0, which is what mathematicians call an indeterminate form. It's like asking, what happens when you divide nothing by nothing? It doesn't give us a clear answer right away. When you encounter 0 divided by 0 in limits, it means there's more work to do. We need to find a way to simplify or manipulate the expression to get a meaningful answer. Thankfully, mathematicians have developed some clever techniques to solve these 0 divided by 0 cases. Two common methods are, 1. Factoring. Sometimes we can factor out the terms that cause the expression to become 0 divided by 0. This simplification often reveals the true limit. 2. L'Hopital's rule. This rule is like a secret weapon. If both the numerator and denominator of our limit approach 0 or infinity, we can take the derivative of each and then try evaluating the limit again. Think of it as zooming in on the function near the point of interest. Let's illustrate these methods with an example. Suppose we want to find the limit of x squared minus 1 divided by x minus 1 as x approaches 1. If we directly substitute x equals 1, we end up with 0 divided by 0. However, we can factor the numerator as x minus 1 times x plus 1. Now the x minus 1 terms cancel out, leaving us with the limit of x plus 1 as x approaches 1. Substituting x equals 1, we find the limit is 2. Mastering limits takes practice. Don't be afraid to experiment with different methods and work through numerous examples. Remember, the journey of calculus is filled with intriguing puzzles like 0 divided by 0, and solving them unlocks a deeper understanding of the mathematical world.